Let's take a look now at how we put this all together. That is, we use the quadrilateral properties together with congruency. Let's go and take a look. So in this example here, it says that given that ABCD below is a parallelogram, prove that BEDF is also a parallelogram. Okay, what do we know here? ABCD. ABCD is a parallelogram. So that's parallel to that. That's equal to that. We've got to prove that BEDF. So we need to prove that this one in here is a parallelogram, given that the green one is already a parallelogram. Okay, and they give us a hint that we need to work with congruency. So perhaps what we need to do is see where we've got some interesting equal things. If we look at ABE, triangle ABE, and we look at triangle, for example, DCF, triangle DCF, do we have a few things equal? Well, because we've got a parallelogram, we can see that AB, the side AB in this triangle, equals the side DC in that triangle. So we can say that AB equals DC. And that's given because we've got a parallelogram. So that's one fact we've got sorted out. We're also given in the diagram that E1 is 90 and that F1 is 90. So we can say that E1 equals 90 degrees equals F1, which is 90 degrees. And that's also been given to us in the diagram. So now we've got a side, we've got an angle. What else do we need? So if we've got a side and an angle, we need another side, so or another angle. So what else do we know in this triangle, in this triangle? Well, we've got parallel lines here because of a parallelogram. Do we have a Z? So if we look at this, if we go there and we go down and then we go up, there is a Z. So this angle A1 would be equal to angle C2. And what would the reason be? Angle A1 equals angle C2. That's because you've got alternate angles, and that's because BA is parallel to CD. BA is parallel to CD, and that's also given because you've got that ABCD is given as a parallelogram. ABCD is a parallelogram. Okay, so now we've proven we've got a side, we've got an angle, and we've got another angle. So therefore we can say triangle ABE is congruent to triangle DCF, and the reason for that is because we've got side, angle, angle, or we can say angle, angle, side, or we can say angle, side, angle. That's our reason. Okay, how does that help us prove that this is a parallelogram? Well, now that we've got these equal, let's just work a bit more and try and get into these triangles here in the pink diagram. We know that E1 is 90. What is E2? So we can say that E2 is also 90. Why can we say that? Because this is angles on a straight line. So that's 90, and the reason for that is angles on a straight line. So that's good. If we now look at this triangle, F1 is 90, so what is F2? F2 is also 90. So that's also angles on a straight line, and they are equal to 180. So therefore, I've got that this angle now is equal, so that's in that triangle, equals this angle here. So we've got these two equal. Now, if these two angles are equal, I can see a Z. If you go up there, down there, and across. If these two are equal, it must then mean that BE is parallel to FD. So we can now say, therefore, BE must be parallel to FD because we've got alternate angles equal. So this is now parallel to this. But because we've proven that this triangle here is congruent to this triangle here, what can we say about the side BE and FD? We can now say that BE actually equals to FD. This whole side equals FD. Why is that? That's because we've already proven that triangle ABE is congruent to DCF. So once you've got this triangle congruent to this triangle, This side here is a corresponding side to this one here. Both pink sides are corresponding sides. So we can say B equals FD, the reason being, we've already proven that triangle AB is congruent to triangle DCF. So in fact, what we've now proven is that both BE and FD, BE is both equal to and parallel to FD. The sides are equal and they're parallel because of these alternate angles, and therefore we've proven that BEFD is a parallelogram. So we proved that BEFD is a parallelogram by using that fact that in a parallelogram, one pair of opposite sides have to both be equal and parallel. How do we do this? By proving the two triangles were congruent, we've got the sides equal, and by getting the angles in the Z equal, we've got alternate angles. So we've got parallel lines from the alternate angles and equal sides from the congruent triangles. So one pair of sides is both equal and parallel, therefore it is a parallelogram. Let's take a look at the next one.